Hi there. So I think topic 5-2 is kind of fun. It's called piecewise defined functions. You will need some graph paper, so please go print one if you haven't already done so, or if you don't have any available. We will be in the book, pages 191 to 196. Just before we get started on the notes, I just want to, it's going to go in crooked here. Just wanted to talk to you real quickly about the absolute value function. See how it kind of goes one direction on the left side and one direction on the right side? Those are two different pieces. That's why they're called piecewise defined functions. All right, now let's go to the notes. You can title it 5-2, piecewise defined functions. And the main point is you need to know that there are different rules for different pieces. And by pieces, I just mean the intervals, like the left or the right-hand side of that absolute value equation. I think we will actually start off with an absolute value one. That's probably a good one to do. We'll call this example 1, and f of x will be 2 times the absolute value of x. Now, like we learned in the last lesson, if you make a table, it's going to kind of repeat itself. Like if we used -2, 0, and then, let's do -2, maybe -1, 0, 1, and 2. This turned out to be the vertex. We got that off the parent function. And then they kind of repeated. So the absolute value of -2 is +2 times 2 is 4. The absolute value of -1 is 1 times 2 is 2. The absolute value of 0 is 0 times 2 is 0, and then it does repeat. Now, what you need to notice in this lesson is that when you graph the points, notice on the left-hand side, they're actually going down. In other words, it's turning out to be the opposite or a negative value, a negative slope. This side is going up or positive slope. I can actually take this function and split it into two separate pieces. When we do that, we write our function. We use kind of this giant curly Q where we're going to put the pieces. I notice that in every case, it's 2 times this value if you are on the right. 2 times 0, 2 times 1, and 2 times 2. So it becomes 2x. When does that happen? Well, only if that x that I picked was greater than or equal to 0. Notice for these, well, I am still doubling, but I'm also changing the signs. So this is -2 times -2. -2 times -1, etc. So I'm going downhill. -2 times the value. Where does that occur? Well, that occurs when the x's that I pick are smaller than 0. And those are the two pieces. Now, for today's lesson, you'll be given the pieces, and your goal is to come up with the graph. If you have a good handle on y equals mx plus b graphing, this is going to be really easy. If you don't, you need to go back and review that m is your slope, which is your rise over run, and b is your y-intercept. In other words, your starting point. All right, let's do a couple of examples where we actually start with the pieces. Example 2. The function that we're going to graph is split into two pieces. It's going to be x plus 1, where the x's are less than or equal to 2. it's going to be negative 3/2 x plus 6, where the x's are bigger than 2. Okay, setting up our graph. I think a pencil would make this really better for you. I'm going to try to draw it in lightly, and then I'll go back in and color it in with red. If I were to graph this, I notice that I have a y-intercept of 1 and a slope of up 1 over 1. So this first piece would be a line that looks like this. But I only want that line where the x is less than or equal to 2. So I really only want the line from here down. I don't want that top part. So I'm going to mark that part in red. Okay, this part has a y-intercept of 6, and its slope is down 3 over 2. Down 3 over 2. So it would be this pencil line here. But I only want the piece of it that's greater than 2. So from here over. So I don't want this part of the line. I only want this part. Notice it looks kind of like an absolute value graph, but the vertex is moved to a different spot. So if you were ever to see this on a multiple choice, make sure you pick the piece that only looks like what I have marked in bold. All right, let's do another one. So I write kind of big, so for the last example, I'm going to go ahead and switch to another piece of graph paper. You might have room to continue, though. It is example 3. This function has a piece of x minus 2 where x is less than or equal to 1. It has a piece of negative 2x plus 3 where x is bigger than 1. Okay, for the first piece, my y-intercept is negative 2. My slope is up 1 over 1. Up 1 over 1. Now, we only want that piece for the x less than or equal to 1. So here is the 1. So I only want this portion, not this part. For the second piece, I have a y-intercept of 3 and a slope of negative 2, so down 2 over 1. And this piece has that graph, but only where the x is bigger than 1. So here's the x of 1, and it's bigger. So it's that part, not this part. Now, so far in the first two examples, they came together as a V. Now these don't. There is a jump from here to here. So remember the whole open circle, closed circle part? Well, this one, which was right here, included the 1. So it has like a solid dot. This piece of the puzzle did not include 1, so it has an open circle. It's kind of hard to tell because I use such fat markers, but this is open and this is closed. So if I were to ask you which piece, if x equals 1, would you use? It would be this one. So if x equals 1, 1 minus 2 is negative 1. That's why this point is closed. Okay, hopefully that makes sense. You're going to go now and work on page 194 and 195. You've got 5 graphs to try. Be sure that you try them before you start entering your answers into Google Form. And of course, be sure to watch the video to check your answers before moving on as well.